So I told myself I'd do this, but I genuinely only have an hour. Anyway, so let's try this. All right, so let's go. Linux is a microcomputer predecessor pre-1996, also known as Y Linux. I really value accuracy, so if you find any mistakes, I built something for you to correct me here. I promise to leave this URL live until at least 2034. You'll also find the script I'm reading. This is a general talk, so here are some of the players for 20th Century Journey if you haven't met them. Let's warm up the time machine. We all use Linux, even if we don't know it. Whenever you see a machine reboot at a grocery store, it's like, oh hey, there's that penguin again. Linux has arguably become the most ubiquitous operating system. How did that happen? This is the story that's usually given. An undergrad in Finland posted about his hobby project, and a bunch of people helped out. Wait, a college kid with a hobby project starting a computer revolution by posting? That's absurd. What about these other things that existed? They're only the Unix-ish ones. Oberon by Pascal's Nicholas Wirth is from 1987, and there were other more minor ones we found in the back of magazines and long-forgotten Usenet posts. These didn't even make the deck. But these did. Here's various commercial efforts. Some of these are complete systems, others are kernels. The point is Linux wasn't shouting from the wilderness. There was a vibrant Unix on the PC ecosystem. Oh, I'm redlining this damn thing. There was a vibrant Unix on a PC ecosystem that predated him substantially, an industry which hasn't had a lasting impact. Products such as Xenix and Coherent were hot stuff at one time, but now are the works of Ozymandias. Look on the timeline, ye mighty, and despair. That's because this guy, Genghis Khan, the Unix war. I could only find one commercial Unix without hardware attached to it still around. Xinuos Unix Square 7 Definitive 2018, which last release was actually in 2017, and that's it. It's deader than dial-up. But Mr. Mackenzie, there's more to the story. What about the BSD lawsuit? Well, what about it? BSD has a history stretching back to 1976. The two names for our story are a husband and wife team, Bell and Lynn Jolitz. Why didn't that win Unix war? Well, this is usually given, but I'm not persuaded. BSD is much older, and in an interview with Bill Jolitz in 1994, he said he actually started working on 386 BSD when the 386 came out in 1986, even though only something called Net 1 and Net 2 were released in that interim. Also, there were 5 lawsuits that held up Linux in court for over a decade. Did that affect its development? Okay, let's assume there was a 2-year hold in BSD. Then we should go over to, say, Usenet and see a fair amount of silence during the time. But in fact, we don't. This is just over 2 days. It was lively and vibrant. There's no evidence of any chilling effect. The highlighted post is an update on the lawsuit amidst a bunch of articles talking about progress and bugs. I mapped out the velocity of 36 BSD Usenet articles and tried to see if there was any chains correlated with the court case activities. And although I'm not a data scientist, they looked completely unrelated. Lastly, there's a number of articles across Usenet with titles like Linux or 386 BSD, where people compare which one they should choose. Although many include minutiae such as specific hardware, none of them talk about the lawsuit. So I have to reject the hypothesis that BSD was held back because there's no contemporaneous evidence. Tell me how wrong I am, go to the URL and denounce me at your leisure. Regardless, Linux has become a few orders of magnitude more prevalent than BSD and eclipsed all other Unixes. Why is that? I present 2 possibilities: the great man theory and a social hierarchy. The second is harder. Let's try the first. That sounds really easy. It says some glorious thing happened, but you cannot do it because you don't have the right genes. Unfortunately, that isn't useful unless you enjoy sulking about things you consider flops. But you're all rock stars, right? So let's look at the second. Using the power of syllogisms. Mere mortals did this. We are mere mortals, therefore we can do this. But only if we know how. Okay, the first is a much shorter speech. A Thomas Carlyle style hero worshipping about how great men should rule and others should revere them. I could have made a gushing mystical biopic. However, we've got a much harder task. And to do it, we must have defendable, falsifiable, maybe even testable hypotheses. But first, here's some more jargon. Perhaps Linux was the second act of the personal computer revolution, personal software and personal hardware. If the center will not hold, things fall apart, and mere anarchy is loose upon the world, we might as well make it productive and get nice software out of it. Blue to black to white. Maybe a free Unix needed a pool of hackers to build it on cheap computers with a robust communication network and avoid bad actors taking advantage of the generosity. Maybe. There's also the maybe not, that falsifiable thing I was talking about. Unix was thought to be really complicated. The Unix source license was $200,000 in the 80s, so of course it was complicated and magical, but that was all marketing. Okay, no. Actually, it was seen as quite elegant and simple. Yes. Even 386 BSD, 20 years into Unix, was done by the Jolitzes, the husband and wife team, just 2 people. Community-based programs were thought impossible. There's an organization called Share that started in 1955. An organization called Share started in 1955, who came up with the Share operating system in the late 50s, which was you don't have to do that. You already know it. Who came up with a Share operating system, which was community developed, where people would share the source code. This was eventually structured closer to a buyer's cooperative. To see how it worked around the birth of Unix, let's go to Computer World in 1968. During the past 4 months, the Share DOS Share DOS project has been working with IBM to define changes needed by users. When the company responded, 12 of the 13 requests had been turned down. Well, look what happens when you ignore the users. Oh yeah, Share was based out of Los Angeles, so LA Pride, I guess. Speaking of things that happened before I was born, this is ancient history. Although Unix started in 1969, the first paper was in 1974. I've extracted 4 principles from it that will be useful for our journey. Leverage, don't invent. Doing beats planning. Needs, not desires. Use early, use often. Although each of these may have its flaws, together they form a cohesion, even a synergy, if you will. Unix was designed for classic computers that died out called microcomputers, or mini-computers. They were an order of magnitude or 2 cheaper than mainframes and also less capable. At first. People wanted to solve their mainframe tasks on cheaper machines because that might have been all they had access to. Let's do it. Roughly every decade, a new lower-priced computer class forms based on new programming platform, network, and interface, resulting in new usage and the establishment of a new industry. That's called Bell's Law, and it's from 1972. As mini computers came on the market and became more powerful, Unix was there to leverage them to service people's needs. These new machines provide a new context for new software. These needs are only meant as examples. The point is the velocity of computer progress went faster than people's needs. You could say it looked like the computer performance increased as a square of the cost, and that transistors per chip doubled every 18 months. Those are called Grosh's Law and Moore's Law. Together, it meant the industry eventually ate itself through a multi-decade-long digestion. However, when new things come in, the people who get there early don't get there easy. It's okay, though. Some of us are crazy and prefer it. AT&T was under a lot of legal restrictions, and because of that, Unix was initially distributed as if it came out of the back of a marked white van. The chart on the right was put on the standard presentation deck for early Unix, saying you're on your own. Think of the adventure, the excitement. But who are you catering to with such a message? Where will the behavior of those people take the project? It's not about welcoming everybody doing anything. With any of these efforts, you have to ask yourself who you're bringing to the door and what kind of behavior you're expecting. That's what separates a library from a soccer field. For example, Linus, October 1991. You also need to be something of a hacker to set it up. So for those hoping for an alternative to Minix 386, please ignore me. It is currently meant for hackers interested in operating systems and 386s with access to Minix. Maintaining focus is about intentionality, not incidentally, but actually intentionally choosing what to ignore. You have to be a clear signal amongst our noisy world. Because you had to know what you're doing, Linux was initially introduced through engineering and technical people and not through the conventional decision makers. But it worked, and by the 80s, Unix was mainstream. It's a success, but not so fast. As both the consumers and the producers of Unix multiplied, the suppliers differentiated themselves by succumbing to the trappings of usual competitive markets. You call this enclosing the commons, trying to take ownership of groups and commonly held things by setting up barriers so you don't lose them, thus locking them in and growing your base by trying to look special. Unix had infected everything from workstations to mainframes. Unisys, one of the mainframe makers, had an article in September 1987 issue of Computer World predicting a tripling in Unix sales over a single year. The problem with the infighting goes back to the chart with various blobs around computer classes. The threat is almost always coming from below. In this case, it was a Microsoft and microcomputers, and not Nixdorf Cynix on an NS32000 versus Clix on Intergraph Interpro. In 1985, Microsoft argued that their Xenix Unix, which had an install base of 100,000, would be a multi-user version of DOS. In 1987, they said they didn't see it competing with their plans for OS2, which at that time was seen as a successor to Windows 1.0. I know things changed, specifically that December with the introduction of Windows 2.0, and later with Windows for Workgroups and NT. That was the real threat. Anyway, in 1985, Xenix required 12 360K floppies, which was seen as bonkers. And how did I do this? I'd show them. Like 12 360K floppies. In case you're even younger than me, a 32 gigabyte micro SD card is about 93,000 floppies, 190 meters stacked end to end. That's like a 2.5 minute walk. All that storage is now in the size of your thumbnail and costs as much as a taco on the west side. Anyway, software distribution used to suck. Speaking of Microsoft, that punch tape is how they distributed BASIC for the Altair in the 1970s. It took about 20 minutes to load, and of course it wasn't then stored on disk because the Altair didn't have one. Just keep the computer on if you want to use the software. It's also worth noting in the lower right, that's called a type-in program. Software used to be distributed like this, also as multiple pages on hexadecimal. Software used to be distributed like this as multiple pages of hexadecimal. I'm serious. No, I'm serious. In fact, I need to cite that thing. Cite. This is MLX format. They publish listings like this every month. For years, you typed it in. Oh no, I say it right there. There was no electronic reader. You can see some of the basic code from the first page, and it's not pretty either. That QR code is this game running on an emulator in your browser. You can scan and just tap on your phone. No typing required. You want to try it out? I'll give you a few seconds. You can only use software that you have access to. For many people, that meant retail or mail order channels. You can also copy a floppy from a friend. The bottom two methods had consumer overhead. For dial-up, you usually had to pay an expensive phone bill, and for internet, you probably didn't have it. This means most people were only exposed to the top three groups, and thus was difficult for smaller developers, especially non-commercial ones, to get their software to the masses. Quoting Marketing High Technologies by Bill Davidow in 1986, it's not a product without a distribution channel, or in Lynx's case, a distribution. The technology may have the potential to address the needs of many, but without specialist redistributors to put it in the hands of those customers, it will not succeed. Products are sold through distributions, not to distribution. I need to jump forward to the why Linux question here for a bit while this diagram is up. Linux had a high accessibility of the install media. Not only were there websites that would mail you CDs for $1, but you could find them at coffee shops, libraries, and attached to magazines at the grocery store. Filling up a CD with a Linux distro and heavily cribbling a bunch of well-written how-tos was cheap content for a magazine producer who just wanted to get an issue out. But there were even more problems. Depending on the distribution channel, updates had different logistic complexity, especially when considering updates from outsiders. For instance, if you wanted to update, say, the retail version of Lotus 123 and have you change it appear on the shelf at Circuit City, you'd probably have to do it yourself and get arrested. It would have been really fun, though. Once there were online networks, which could provide the storage and communication necessary to unlock multiplayer online mode for the software development game, a new form of writing software was created. Yaki Benkler made up the term Commons-Based Peer Production in 2001 and wrote a book about it called The Wealth of Networks in 2006. Let's go back to Linus in 1991. I've enjoyed doing this, and someone might enjoy looking at it and even modifying it for their own needs. It's still small enough to understand, use, and modify. I'm looking forward to any comments you might have. I'd like to hear from you so I can add your software to the system. Stallman has a Rooseveltian list of GNU. I would say GNU. As a Rooseveltian list of 4 software freedoms to define free software, but for our purposes, we're going to talk about horizontaling software development, or what I call adoptive, because it's not just a license, it's organization plus license. Essentially, how easy is it for modifications to become integrated and in the same distribution channel, and other people to become a distributor or share your product? You need not only a decent legal structure, but also a software organization structure that affords this, and an open shop that permits anyone to come in. Eric Raymond touched upon this in his seminal work, The Cathedral and a Bazaar. There is the Cathedral model, which is tall, in which source code is available, and each software release but code developed between releases is restricted to an exclusive group of software developers. That's too wordy. Refactor contrasts this with the Bazaar model, which is flat, in which code is developed over the internet in the view of the public. The vertical lines here, from permissive to restrictive, is a general continuum. Public domain is seen as too permissive in the eyes of GNU because you can relicense and reprivatize things for different purposes. I've also read that copyleft and GPL are different from each other, but I never went to law school. If you zoom in, you'll see non-computer things. I'll go over a few for people to get a sense of what this is. Bottom right corner is facts. People ought to really be hesitant to modify facts. In the US, they're considered public domain. Above that, you have most religions. I can say preach the good word and start up a congregation, But at least in principle, the texts are sacred and inviolable. As we go up, we get to jokes, recipes, human language, and at the top is folklore, which changes readily. Also at the top, as you move left, to the more restrictive, to left of the public domain, you get Wikipedia, which anyone can edit. An interesting adoptive entry on the restrictive side is social media. Anyone can contribute, but the platform retains a bunch of rights. Yeah, platforms retain. Classic commercial software is all the way down here in the hesitant and restrictive camp. The pink stuff is all Linux related. If you're colorblind, it's right here. No, point to it. Minix is down here next to freeware and GCC in the hesitant category, below the pool labeled Unixes. Except for social media and Wikipedia, all of this is early 1990s, not 2024 accurate. Speaking of the past, let's go to the introduction of Minix. In 1986, commons-based peer production wasn't feasible. People didn't have the internet in their pocket like you do. Because of the prohibitive logistics around software distribution, updates especially customer-initiated, Minix was a cathedral. Also, it's worth noting, it was a product of Prentice Hall, who wanted to sell textbooks and, of course, course material for Andrew Tannenbaum. And instructional. So I want to do of course there. So here's the relevant parts from the announcement. It's not public domain. However, the publisher does not object to people making a limited number, making copies for friends. That is SneakerNet. If you want to sell it, which is the two categories above SneakerNet, retail and mail order, you need permission. In the book, you will find a postcard that you can use to order software. That's our mail order again. And he says that he doesn't want to copy a bunch of floppies, as in do SneakerNet, and then at prices of $80, which is really cheap. Commercial PC Unix generally start at $1,000 without the source. Now, I also mentioned it was adjacent to Minix. Was adjacent to GCC. What's up with that? GNU was also a cathedral. Here's an example from an early GNU bulletin, 1987. We can see it listing out different distribution channels as they solicited funds to pay programmers to write more software, like an engineering firm might. They played a second role as a provider of copyleft and eventually software under the GPL, which came out a few years later. Every bulletin had a growing list of software by others that you can order basically at cost. As far as this goes, there's precedents. Here's one from 1976, trying to be a repository for, at that time, public domain software from smaller producers, such as code published in, say, Dr. Dobbs' journal. Some assembly programs ran over 40 pages long that you, of course, were expected to type in yourself. So people were looking for a more reasonable solution that didn't cost as much, but not all the pieces were there yet. All of these things required labor, coordination, and resources, and how you chose to instrument those made some things more possible than others. Ideas are bizarre, even when their implementations are cathedrals. For instance, there were many graphical desktop computers, even though each one was a proprietary restrictive project. The superstructure of desktop computers operated in the adoptive space. Pretend we have a concept of free operating system. We may not get all the parts right in the first try, but the Platonic ideal exists. Well, kind of. It's as much of a contemporaneous invention as anything else, as a pale true thought suspended in our life stream. We can go back to Vannevar Bush's Memics article, as we may think, in The Atlantic from 1945, to see the spirit of what we now call many things. Unlike products, Platonic ideals are collective projects owned by nobody. They are permissive and adoptive. And not static abstractions divorced from human influence. They are ideals manifested from context. The map is not the territory, and in our industry, we're tasked with creating both through pure thought stuff. What a responsibility. We better get organized. Oh, how did that work? That way. This is about the complexities of building software, and not about electing people. You may have heard that commercial software began with Bill Gates' open letter to computer hobbyists in 1976, where he announced SneakerNet distribution of Altair Basic because he didn't get paid for each of the copies. That's not really where commercial software began. In the mid-1950s, software was in-house coupled with hardware, or contract-based, as you can see in this 1959 ad for a programmer from Punch Card Data Processing. But the version of commercial software that had already built stuff you purchased copies of for a computer you had already owned had existed since the late 1960s. No, really, This is another falsifiable thing that I want to go over. Bruce Perrin's chapter on open sources, Stephen Levy and hackers, they all allude to this Garden of Eden from the past, from which we have fallen, where software was once free. Really? Well, no. Here's 1966 claiming commercial software was a $100 million industry. And then in 1969, 11 companies worth at least $100 million got together to fight off the not-for-profit efforts. The manufacturers bundled software to lock in their customers, like Microsoft did with Internet Explorer. It was as free as Windows is on a laptop you buy. People were trying to DRM and patent software back in the 1960s. Maybe there was some idyllic Valhalla in the bubble known as MIT Artificial Intelligence Lab, but the real world was up to the same tricks they are now. Anyway, deep bundling happened in 1968 and 69, vendor by vendor, and Unix arose from this primordial soup as one of the oldest non-mainframe software that is still recognizable today. I say recognizable because the family tree looks like a European dynasty. This Unix timeline history chart covers a few years in the late 80s. If you were to zoom in, you'd see Minix, MIT Trix, SunOS, the Mac microkernel Xenix, from the House of Free Software, AT&T, or the Kingdom of Microsoft. I'm still not a lawyer, but this is really complicated. Not only did the source and binaries have different terms, but sometimes only certain organizations had access to them. It actually gets crazier. Things had a sort of past. For instance, if you were an educational... No. Take that one out. For instance, if you're an educational organization with a pre-existing AT&T license, then you had access to BSD. So a version might have multiple parents, each with different term sheet. It's a legal Habsburg. That's why a few slides ago there was a puddle labeled Unixes. Even the Unix term itself is a confusing mess. Raise your hand if you still think it's copyrighted by AT&T. If you think it's copyrighted by AT&T, yeah. No. 30 years ago, AT&T sold, or over 30 years ago, AT&T sold the copyright to Novell, who then donated to the Open Group, which is now a standard organization. Some Linuxes have gone through the process, so Linux is now a Unix. Really? You're just finding that out right now? This stuff is absurd. We need something with clean, documented history, a clear license, and easy answers to all these problems. So Linux and effectively all modern open source projects have this solved. All development is open, the history is well archived, and OSI-approved licenses solves the family tree problems. The structure that's now ubiquitous is one of Linux's major contributions. Also, let's talk about the internal politics of software building. In the abstract penguin slide, we cover the outside aspirational curve, where things take decades and opinions are strong in many. Things like paradigmatic ways of doing open source software development took 20 years to become dominant because of the longevity and applicability of the more abstract solutions is also on the same time frame as their implementations. But within that exist lower-level Maslowian motivations, and keeping the things there make them more actionable. Let's say my network card isn't sending out packets. We can say that bug is known, agreed upon, and demonstrable. So although it may not be easy, the labor path is reversible. Now a new network card comes out, say an NE2000. I need it to work in Linux. That's a need. I can demonstrate and come to an agreement on what that would look like. Now pretend I wanted to do something I wasn't designed to do. That's harder to demonstrate and agree upon. To get that actionable, I need to pull the desire into the lower curve so the development cycle can encompass it. It's worth noting the Tannenbaum-Torvalds debate from 1992 to illustrate this. Tannenbaum chastised Torvalds' approach because it wasn't a microkernel and Linux was exclusive to 386. Really, Linux was on the lower true curves, and Tannenbaum was trying to pull it up to the higher curves where things move far slower. GNU-Hurd was a microkernel approach. Stallman claimed in the early 2000s that's why it was taking so long and wasn't very stable. The point is that the higher level curves are unlikely to succeed except as superstructures of the lower level functions in the same way that our asymmetric approach to Platonic ideals happens on the back of incrementally more appropriate implementations, which is why you can snake a line from the 1950s IBM share organization to GitHub. Through the process of clarifying the aspirations, they get moved to the concrete because they become material needs and bug problems. The clarity of the present stands on both the triumph and the wreckage of the past. If you don't need to know the history of a spoken language or any other system in order to use it, but it doesn't hurt. Chapter 6. The prices. If you understand the price of everything, you'll know the value of most. I found both an article and an advertisement from May 1990. Sun says they have a cheap $6,700 computer. Here's a PC at about 1/10 the price, which is fine if you can do some of the same things. Historically, that answer had been no, but referring back to the chart with computing needs and computing classes, this dynamic was likely to change soon. The 386 had many technical features that made it more appropriate for Unix-style operating systems. There's an adage about this: what Andy Grove giveth, Bill Gates taketh away. In this case, the new software was Linux, and it was consuming the increasing capabilities provided by the 386. But that's not the only kind of price there is. I might actually drop that one. I don't think it adds. There's also the price of time. This is a conceptual, not a quantitative graph. Essentially, Windows is the easiest to get up and going, but let's say you wanted to do something like batch convert a bunch of files, or sort the contents, pick a field, extract the values, do some operation on them. These things get hard fast on Windows. Even on 386 BSD, and it's got... Early on, 386 BSD and its cousins were a pain to set up, but they had networking before Linux. It was a more sophisticated project. However, there were fewer people working on it who tended to be more experienced, so they were busy and expensive. Linux was mostly students, which are famously cheap. It was also heavily hobbyist-oriented, which usually meant that the systems were more hackable, while the other Unixes, they presumed that you had something important to do. The more difficult and time-consuming it is for a customer to use an information system, the less likely it is that they will use that information system. That's Calvin Morris from 1959. As the complexity of the problems become more intractable, the approachability of the lower levels and internals of a system become increasingly important because people tend to use the most convenient method and the least exacting mode available and stop as soon as minimally acceptable results are found. That's the principle of least effort. Hackers tend to build worlds where everything is possible, but nothing of interest is easy. Alan Perlis called this a Turing tar pit in 1982. Pulling yourself out of a Turing tar pit from a capable to a usable system requires some engine to push it forward. Our Wordy Commons-based pure production model from before can be seen as prosumer, a producer and consumer put together. It's used often for social media, where you are consuming other consumers' productions. Here, our engine is problem-solution integration, which keeps us in the bugs needs development cycle. With the Bazaar method of development, the changes reflect back quickly, which means that new users have fewer problems with their different hardware, so that other people with, say, an NE2000, it will just work. But where do you find the people to do that? Well, you have to build armies, of course. Large networks are important. Their utility can scale exponentially with the size of the network. The number of combinatorial subgroups, participants from these larger collections grow more rapidly than the original utility of the groups that joined. That's Reed's Law from 2001. For example, my friend and I start using Linux. I have an 82000 card that doesn't work. I now join the subgroup of people becoming a we that needs this to work. This only becomes an engine if you have the right people to complete the cycle we talked about. The lowest level here are the enthusiast developers and bug fixers, followed by the curious hobbyists, and then the business needs and people like power plants and airplanes that can't have things fail. Arguably, one of the failings for early BSD is that they were too lopsided on the higher steps and thus couldn't get the virtuous cycle moving with enough velocity. I analyzed the email addresses of about 2.5 million Usenet posts over a 2-year period, and you could see that there were almost always more commercial emails from BSD and almost more educational ones from Linux. So even though the general trend was ascending the staircase, Linux had more torque from the bottom groups. I call this the Linuxist revolutionary theory. The hacker vanguard forms a coalition with a personal computer proletariat, and a business-oriented bourgeoisie becomes interested, and finally a prohibitively assiduous aristocracy is able to use it. There's one last type of price, and that is of expertise. Whether it's your own or you're fronting some cash, it's expensive. You could roughly assign a utility function as the capability is divided by the effort required. Sometimes both capabilities and experts and effort increases over time. Blender, for instance, is highly capable software, but also takes a lot of expertise to use effectively. Many mobile and web apps are, on the other hand, actually remove power user features over time to make the power product require less effort while also making it less capable. Still, other software APA and frameworks can have Fred Brooks' second smell effect. They have a new version that's far more difficult to use and leads to inferior results, thus being the inversion of the graph and decreasing the utility of the product. Let's talk about the multiple arrows. In order to get a larger user base, you need a diversity of capabilities requiring a diversity of effort. Linux was able to achieve this by outsourcing the actual packaging of the OS through distributions. This is another insight about the Bazaar software model. Since the entire structure is more flat and the structural organization barriers are mostly removed, as markets naturally subdivide and form, they can be quickly and readily addressed. Because we're doing social history, I'll use critical theory and Marcuse's idea of de-radicalization. The dominant structure, say markets, subsumes the novel. However, because in Bazaars people can self-organize, they beat it to the punch and move faster than market force, which is why open source decoupled software structures are more dynamic and swift-footed than commercial approaches. Here's a chart from Innovator's Dilemma. It's describing different strategies that can be taken as technology gets better. You can generally either push up market or to higher-end customers, or which are the top two steps of the stairs, or you can stay with existing customers, which might be the lower steps. However, because of the horizontal development of Linux and the existence of distributions run by multiple organizations, it was able to do multiple strategies at once. Not only these, but any other ones that haven't left out of the graph. Chapter 7, the packets. A few slides ago, we saw how Linux was a horizontalist, bizarre approach to software internally. Let's look at the implications of this externally. This chart is taken from Andy Grove's 1995 text, Only the Paranoid Survive, describing how the industry moved from a one-stop shop vertical to horizontal structure. If we put this in aspirational space, this can be viewed as part of the same decoupling superstructure as what the mainframes were doing in the late 1960s. Just do that. The premise of this transition was a book called The Coming Computer Industry Shakedown by Steve McClellan in 1984. Quoting, as software gains ascendancy, a new world will rise and characterize the activities of the industry. The keyword will no longer be customization, specialization, and market niche. The new world will be integration. Systems integration will be the most sophisticated and difficult task for companies will have to undertake. That quote, being 40 years old, gives us the privilege of seeing what happened. Essentially, 4 strategies were developed to tackle this problem. The first is to impose on the vertical by claiming you're the standard, but in practice only one player can do that, so OS/2 died. Apple took a different route by being its own vertical, and Linux had to push the wheel out of the tar pit and need enough people to do it. Luckily, timing was on their side. When the internet was mostly accessed at universities, September annually brought in a flood of new people that had to be coached. However, as residential internet grew, the old guard termed 1993 as the eternal September, the beginning of the mainstreaming of internet access. For this to happen, cheap ISPs and web servers needed to exist quickly to support users. It's important to note that Linux was prima facie hobbyist and personal use oriented at that time. Linux Journal has articles in 1994 about it as a web server and running ISPs. However, 1994 texts such as Linux Getting Started, Unleashing the Workstation in Your PC, or Plug and Play Linux from 1993 were the lower 2 steps of our staircase, hobbyist and personal. The early Slackware and SLS distros from the time also didn't include web servers or tools to run a business. The first people on the subsequent use case steps didn't get there with clean off-the-shelf solutions. They played the scout role, clearing the road for the army to roll in, which is why the web server book in 1995 now includes Linux. Another benefactor of the eternal September is attributed to Linus's law. Given enough eyeballs, all bugs are shallow. Let's look at the various eyeballs. In the first term slide, I said Linux was mostly built by college kids. Here's some evidence. After the first posting in October, Linus got some help from a local friend, but by November he had contributions from Hong Kong, MIT, and University of Utah. In December, contributions came from Calgary and Berkeley, and then Colorado and Maryland students contributing in January. So far, everyone is under 25, and as I said before, there became an increasingly pressing need for a solution like Linux to solve new problems. And those needs have more or less persist to this day. Apple is vertical, Microsoft is entitled, and Linux continues to climb stairs that have yet to be drawn. Here's a nice quote by Torvalds. It's worth reading. I think the timing was good. Even just a year earlier, I don't think it could have been done. And a year later, somebody else would have done something similar. Okay. These 2 bottom charts show how Linux now dominates the supercomputer and web space. Let's do this. How's everyone doing? I hope you're still awake. Yes, that's typed on the sheet as well. I know this is long, so let's have some fun. If there was a storefront named Open Source, what would be displayed on its windows? In fact, let's do some interactive theater. We are a group of people in 1995 trying to bring free software to the masses. Our marketing director just told us about the marketing mix with 4 Ps. Product, price, place, and promotion. It should be, in order to have a figurehead for the free software movement, we need to find a piece of free software that qualifies these conditions. It should be easy to try, acquire, and understand. It should have a high price of time and should have a low price of time, money, and expertise. I appreciate the suggestions so far. These are all excellent examples of free software, especially like the elevator pitch for Emacs Org mode. Before we settle on a project, I'm wondering if we've left anything out. Any suggestions from the audience? Oh yes, you, sir. The man I've known for over a decade. Oh, that's a great idea. Maybe Linux can be the window dressing of the free software movement. Or how about this? I have an even better idea. Let's make an alt copyright pipeline. We have low effort things for curious PC users to try. Then we tell them the beliefs of our community and get them up their commitments. As they do, they become more familiar with projects which take effort and expertise, get more involved, and be an advocate for them. Over time, some of these people will aid us, if we're lucky, in reporting bugs, determining needs, and implementing desires to move our aspirational project forward to make it more tangible. In order to do this, we must be a welcoming community, by necessity, but also because we brought in the right people. So, that's how it happened. Oh, wait a second. How do we do it again? The final boss. Geoffrey Moore proposed this graph in his work, Crossing the Chasm. It proposes that as commercial products mature, users with different behavior and expectations come around. There's two holes in his graph. The first group is people who are aspirational and have high tolerance for practicality. They are willing to go the extra mile to make something work. There's a group that's enthusiastic about possibilities but want a lower effort and expertise costs. In this graph on the right, with electric car adoption in Norway, you can see that smaller slump, the first circle. The next group is a difficult one. They're looking for a working product and don't want to be hassled with inconvenience. That's the yellow circle on the graph. Many products don't make it there. The last two are really the bandwagon and the holdouts. Anyway, let's look at this crossing the open source chasm. The first group here are the passionate hackers trying to claw at the aspirational curve and bring it down to the bugs and needs. If they can keep their passions going long enough and make sufficient progress, then perhaps the music makers will come around and help recruit more passionate people to enlarge that base. That's the first pipeline. If the engine between the passion enthusiasts can be maintained in order to get to the problem-solution integration wheel, the project can get pulled out of the turning tire bed, and if the software capability is divided by the effort demanded yield curves enough of a utility ratio. If the software capability is divided by the effort demanded. Yields enough of a utility ratio, then a pragmatist will become interested in the chasm's crossed. But it's important to note to keep the pipeline well lubricated because you'll be facing new challenges and use cases, and you'll need a few of those new users to slide along the responsibility graph in order to grow the coalition as the law of division takes hold. Back when we talked about Platonic ideals being permeable, bizarre superstructures occupied by various executions, I said the clarity of the present stands in both the triumph and wreckage of the past. Sometimes for a city to become great, it must first be destroyed so that a new generation can seize the dream and try to execute it better. Failures unbind us from the commitments and give us permission to kill our darlings and do a page one rewrite by naturally creating space for us to try again, but only if we retain the liberties to do so. Strong IP enforcement on strong visions diminish their chances of success. You must let go of that which you love the most. You may get the vision right, or the execution or timing or team right, but probably not all at once. Facebook, iPhone, Google, Amazon, they're all iterative executions of larger ideas owned by nobody. If you're working on a thing or have a dream and it's just you're definitionally on the very left. You could also argue that for certain use cases, Linux took over 20 years across the big chasm, and for some things, desktop publishing, digital audio workstation, photo editing, or social media, the free software chasm is still not crossed. There needs to be a certain kind of affection for the people, their needs, desires, and aspirations, for these to eventually succeed. For, say, the GIMP to overtake Photoshop. The commitment to others lowering the responsibility chart is key, because that's how you get in new recruits. So whatever you're working on, it will take years and manifest differently than what you thought. You have to not have codependencies with that. That will foster That will foster resentment, anxiety, and low self-esteem. Really, you'll probably become susceptible to the great man theory. If something is dying, maybe that's the fire you need to rebuild things. Listen to the needs and desires of the idea. Do one thing and do it well. Work together, handle text changes because that's a universal interface. This is actually the Unix philosophy by Peter Sallis, but I'm serious about it. Good software advice is also good people advice when building software. Let's go to Tracy Goddard, Soul of a New Machine, 1981. Looking into the VAX, West had imagined he saw a diagram of DEC's corporate organization. He felt that VAX was too complicated. He did not like, for instance, that the system, which various parts of the machine communicated with each other, there was too much protocol involved. He decided that VAX embodied the flaws in DEC's corporate organization. The machine expressed that phenomenally successfully company's cautious bureaucratic style. Churchill said, "We shape the buildings and thereafter they shape us." However, our buildings are different because the programmer, like the poet, works only slightly removed from pure thought stuff. He builds his castles from the air, from air, creating by exertion of the imagination, or so says Fred Brooks. Regardless, wrecking balls for code are cheaper than those for concrete, so don't be afraid of using them. Here's another Unix philosophy. This time, let's talk about in terms of people. Make it easy to write, test, and run organizational efforts. Interactive use with humans instead of batch processing. Make do with smaller teams. You'll need all the engines I talked about to get over the chasms and move the projects forward. Organizations which design systems are constrained to produce designs which are copies of the communication structures of these organizations. Melvin Conway, Datamation, April 1967. We said yesterday to create a better tomorrow. The future's ours to make. Probably. How did I do? Oh my God, 40 minutes. That is amazing. Yay. That means I can slow the fuck down and still make it in like 55. So I'm going to do another one later. I got to get going soon. Actually, I got time now. Oh, I'm good. So yeah, this is Share LA. It's kind of cool. I don't know if they're still around. They were a car sharing company. I'm going to do another one tonight. And yeah, I will probably try to just 2-a-day cadence until I get to a pacing that I like and I don't feel like I'm the Micro Machines guy. So that's it for now. I will talk with you later. Bye.